Hello everybody, today we'll be going over that one problem that always seems to show up with the variable on an exponent at the IB Math Studies level. And so we have that Elvis Presley is an extremely popular singer, and although he passed away in 1977, many of his fans continue to pay tribute by dressing like Elvis and singing his songs. Beautiful, amazing dude. The number of Elvis impersonators n parentheses t can be multiplied by the function blah blah blah. Okay? And where we have that t is the number of years since 1977. Okay, and the number of Elvis impersonators is NT. All right, and so for part A, if we now write down the number of Elvis impersonators in 1977, we need to understand that we are going to figure out the left side of the function, right? So our n, the left side is going to remain unchanged, and what we will be changing is t. That's why I'm not putting a t in here, okay? Because we're going to put a number in there. We're going to replace t for something. And so in this scenario, since it's in 1977, a very common mistake here would be to go ahead and, whoops, sorry about that, would be to go ahead and plug in 1977 in here. Now take a moment to think, why is this a mistake? The reason this is a mistake is because t is the number of years since 1977. So if I were to put 1977 here, I would actually be calculating um, the year 1977 plus 1977. Okay? Another way to think about it is that if I plug in t equals 2, I would be asking the function, hey, in the year 1977 plus 2, which would be the year 1979, how many Elvis impersonators are there? Okay, so that is how to think about it, and it's very important that you read slowly. Okay, t is the number of years since 1977, and so here we would need to plug in, curiously, the number 0, right? And so we have 170 times 1.31 to the power of 0, all right? And anything to the power of 0 is just going to be 1. So this is 170 times 1, which is of course simply 170. And so that is for part A. For part B, time taken to reach the Elvis impersonators of 130,000. Calculate the time. So t is going to be a variable. And we have that the amount of impersonators is 130,000. And so if we plug in 130,000 for the Elvis impersonators on the left side of the function, and we leave t as a variable right up here, we simply need to find the value of t, right? Now, I know this can be complicated because t is on an exponent, and so here, what I highly recommend you do is that you plug this in into your graphing calculator as y1, this is y2, and you go ahead and do calc intersect, okay? If you're not sure how to do this, I literally have a video on it, so go ahead and watch that. And you end up with t equals just about 24.6, and since units matter, you want to make sure that you put 24.6 years, because t is in years. For part C, we're going to calculate the number of Elvis impersonators when t equals 70. So this is kind of like roles reversed from B and C. In part B, t was the variable, and in part C, t is not the variable. And so we will be finding out what is my n of 70, okay, when I plug in 70 for n. When I plug in 70 for t. And yeah, so we go ahead and do that. Plug in 70 for t. And by the way, this in itself is already a whole point, just setting it up. You pop this all into your calculator, and you end up with something like 2.75 times 10 to the power of 10. Okay. So for part D, they give us that the world population in 2047 is projected to be about 9.5 billion people, right? So we need to use this information to explain why the model for the number of Elvis impersonators is unrealistic. Now, first things first, this one is a little bit harder to explain, but also it's only worth 1 point, so don't sweat out too much about it. So, um, the thing is, if we look at the nature of this function, right? To know about the nature of a function, the most important thing to do is look at where the variable is. Okay, and so the variable is in an exponent, right? And we know that this is an exponential function because of it. And so remember when you look at parabolas that you have something like, I don't know, x squared, right? If you have x to the power of 3, or x to the power of 4, or x to the power of 10, this like slope is going to be each time more and more, like intense. And so each time it gets more intense, it grows faster than before. I'm going to say that again. It grows faster than before. And so if I put a really big value for t, my NT, which is the population of Elvis impersonators, is going to grow faster than before. And so in this scenario, since we're talking about the population in 2047, our T would have to be 2047 minus 1977. And this is actually T equals 70, okay? And conveniently, the T equals 70 also shows up for part C, okay? But keep in mind that it grows way faster than before with these big numbers, and maybe 70 already makes it grow a little bit too fast, right? And so if we go ahead and plug in t equals 70 in the function, which is something that we did earlier, right? T equals 70 here, t equals 70 here. The number we ended up with was 2.75 times 10 to the power of 10. And so we need to compare this number to what is predicted, right? And so this number here is 9.5 times 10 to the power of 1, 2, 3, just about 9.5 times 10 to the power of 9, okay? So here it's very important that you know how to compare numbers with scientific notation. And the most important part really is that you need to compare the exponents here. This 10 and this 9. And from there, see which one is bigger, okay? And so essentially this one on the left has like one more zero, or so to say. And so it is a bigger number. So this information shows us that the model of Elvis impersonators is unrealistic because the number of Elvis impersonators cannot be greater than the amount of population in the world, right? Within the population of the world, there will be Elvis impersonators, not the other way around. And so that is how you do part D. Again, I think the most important part in all of these problems, really, I mean, in this problem, the most important part is knowing the calc intersect function, okay? Because part B is really easy to set up, but to actually solve it, you need to be familiar with the calc intersect function. There are other ways to solve it, but I think it's too time consuming and not convenient for you. So that being said, I hope it helped, and I'll see you in the next one.